Hello everyone, March 28th. Alright, yesterday was too sleepy. Way too sleepy. And we essentially didn't do it. But it's not too bad. Because even with very sleepiness, we still figure out how this one should be done. So I guess it's not too bad. It's not too bad. And we know the solution. Yeah, what was the problem yesterday? Keep a heap, using a heap to keep track of the positions. Yeah. All right, let's see what we have today. Apply operations to maximize score. You're given an array nums of n positive integers and integer k. Initially, you start with a score 1. You have to maximize your score by applying the following operation at most k times. Choose any non-empty subarray that you haven't chosen previously. Choose an element x of the subarray with the highest prime score. Highest prime score. If multiple such elements exist, choose the one with the smallest index. Multiply your score by x. Here, the subarray denotes the subarray num starting from L, ending at x. Both are inclusive. The prime score of integer x is equal to the number of distinct prime factors of x. For example, the prime score of 300 is 3 because we have 3 distinct prime factors. Return the maximum possible score after applying at most k operations. So basically, we say each operation will take a non-empty subarray that you haven't chosen before, and we choose an element x with the highest prime score. So why don't we just get the prime score for everyone first, right? We go through everyone and then we just suck it up, do it, right? Suck it up and then do it. We will just divide, and yeah, we will remove all the 2's, and then we'll do 3, and then we'll do 5, and then eventually we'll say if so when do we stop? We stop when the ones we try, like if we square it, it's bigger, right? If we square it, it's bigger because that just means there's no more prime factors in between, right? So yeah, we could do that. Then we get the prime score for everyone. So that's the first barrier to clear. So we get, basically now we get a prime score, right? So now we get here, so we have prime score 0, P0, P1, all the way to Pn, right? That's called Pn minus 1. So this is our array, and then you can now need to choose, and you choose an element x, so to choose anything with the highest prime score. You can do it at most x times. So now we want to find the maximum, because you want to maximize, right? If you want to maximize, then you say, okay, I will find a maximum. Then why don't you just choose one, the single one? Okay. All right, back at it. So, yeah, so now we. So my question is, why don't we just get the largest? Right? After the most, so we just find the k largest. Right? What's wrong with that? For example, this is 1, 1, 1, 1, 1. That is not right. Huh. Oh, holy crap. Okay, I was very wrong. This is a score, this is this. You multiplied by the prime score, yes, and choose the element x with the highest score and multiply by x. Okay, so we need to multiply. So, all right, they're all the same, so we just choose. So it's just gonna be 9, right? And how? It says the only element is separate. Okay, so we get 9. And then we choose separate nums. Both nums2 and nums3 have a prime score of 1, but nums2 has a smaller, hence. Huh? What? Choose any non-empty subarray that you haven't chosen previously. Oh, so if I choose this, and then I can choose this. Dude, and then if k equals to 3, I can choose this. No, I cannot choose this. I can only choose this. Because we have to keep the biggest in the front. Oh, that's very different. Huh, okay. All right, so 19, 12, 14, 6, 10, 18, right? So this is a 1. This is 2, right? This is 2, 2, 2, 18, 2 times 9. This is also 2. All right, so because of this, this can only be chosen once. I can only choose once. And the next one has to be, choose this. So it's 19 times 18. Oh, I can choose one more time. Oh, one more time. Ooh. Ooh wee. So it's this, right? So it's 19 times 14 times 18. 19 times 18 times 14. Yep. I see. Okay, so yeah, definitely we get the score first. So once we get the score, we want the largest number for sure. Okay, so we get the largest number. We get it by itself, right? Then we try to see if we can extend. Yeah. How do we see, like, can we extend? Well, I think you can definitely sort this whole thing, right? You can sort it based on value and their index, right? So you'll get the largest number, you get the index. That's your first choice, okay? And then your second choice will be, well, I mean, if you have the repeat, like the largest number, if it occurs multiple times. So yeah, if it occurs multiple times, then you can. But that doesn't matter, right? So we'll exhaust each largest number first. So okay, we pick the largest number, we have its index, and then from this we start walking to the right to see if we can incorporate the next one, the next one. So these are all subarrays starting from the largest number, right? So we start going right using the score. As long as the score is small or equal to the largest numbers, then we can always expand to the right. So we keep going until we cannot go, right? Then we move on to the next one. Okay. That sounds reasonable. I think the challenge probably is still like to code this in C++. That's definitely one of the challenges. But we'll face the challenge straight on. Agarrar el toro por los cuernos. Alright, so we're gonna first say that's what we think. What the hell happened? Alright. So this is 2818. So what was the idea? The idea is we first of all obtain the prime scores of each element in nums. Then sort nums. Along with its indices, right? Along with their indices. Start from the largest number. So each number we first take by itself, then we try to expand to the right as much as possible, right? Each expansion is contingent on the expanded number's prime score not bigger than the largest number. Each expansion also costs an operation, and but it yields the largest number, right, to the final score. Once all subarrays starting from the largest score is exhausted, we move on to the next. Right, we move on to the next largest number. Yeah, this is like an array, so for each one, and then we just keep going. Okay, so yeah, it's I think the path is very clear, so we just need to do this. Int find prime score. Okay, I usually don't say find. I like to say get. Okay, so get prime score int x. So we need to return return y. All right. So how do we do this? So we first exhaust all. So we say int res equal to x mod 2 equal to 0. Right. If a mod takes a 0 down, we at least have 1. Then we say remove all 2. Say while x is larger than 0, x divide equal to 2. Actually no, that's actually not true. And x mod 2 to 0. I do this. Right, we keep going, we remove the 2, and then remove removal starting from 3. Alright, so we'll call it the p, right, equal to 3, while p times p is smaller than x, right? While x is larger than 0, and x mod p is equal to 0. X divided equal to p, right? And then we come back and we try it again. Right, try it again, and try it again. I need a Boolean value to make sure that it's, yeah, so I need to have a Boolean value. Is prime factor. Alright, I call it false, but as long as one of them succeeds, then is prime factor become true, right? So we'll say rest or plus equal to is prime factor, and p plus equal to 2. Right, we move forward. Right, and I will try, and I will try, and at the end, we'll get out. Alright, it's this one we have to see if it works, right? So we have nums.size, and then we do int p score, and actually I don't need this. We can just say for int n of nums p score dot pushback get prime score n. Alright, so now we got that. Then we're gonna sort this thing. Actually, we have two things. Std vector of std pair sorted nums. Okay, and then we say sorted nums dot pushback. There's an n and I. Okay. And then sorted nums dot start sort begin, right? Begin and I, there's no I, Jesus. Okay, so now we got this for alright, so we have two things. We have index, so we have to have an index on sort. So we have the index equal to 0, right? And I also have k. So we just say while index is smaller than n, right? And k is larger than 0. We need to modulo. What's mod? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's mod. Yeah. Alright, so while this, okay, then we start from index. And we'll try to move to the right. Okay, so we have index. And we're going to say while k is larger than 0, right? And we need to have int I equal to index. This index is short index, so that's actually not exactly what we want. So okay, we're going to say auto pair is equal to sorted nums index, right? And then we say int I p dot p dot second. Let's do the other one. So value equal to p dot first. Alright, so we have value and this. Okay, and then we say while this is larger than 0 and nums I, actually not nums I, should be p score I is because I will move forward, right? So this should be smaller or equal to p score p dot second, right? So while k larger than 0, so which means we have more to go, and the score is good. So once both is good, then we say res shall equal to res times long res times v, that is the value, and I think we can do multiplication works, right? So we do that, okay, and then we need to move I forward because I need to try the next one, right? Let's see if it's still smaller or equal to, and if it's still, we use it. If it's bigger than, then we get out, and also k minus, right? Because we used one operation. So blah blah blah, what we done, accumulate whatever it is that we accumulates. This basically all the subarrays that's starting from the current is done. And then what we need to do is we need to put index forward. Then we go back up, right? And we'll try it again, try it again. And at the end we'll return int res. All right. Let's see. Yeah, I don't. If this one passed, then I'll say yeah, it's not really that hard. It's just has a little bit interesting issue. Hold on. No, we are not right in this one. Why? I only do one of them. Okay, that's fine. We need to. So there are a few things need to verify. For example, I don't know what happened. You know what? I think the best for this is a debugger because it's not really that difficult to get a debugger running on this one. Let's see. This should be nums, and then this should be 83938. Is it 83938? 83938. Yeah. K equal to 2. Alright, so now this one shall be maximum score nums and k. I'll put my thing here. Save. Coming here. This is 28. No, 29. All right, coming back. F5. Go to main. All right, let's see where we are. I don't need this, nor do I need this. I need this. Okay. P-score. Now this is P-score. That should be all 1, so we can take a look. That is not right. Our P-score is not right. P-score. So P-score, I think this showing a 0 because it comes up empty. Ooh. I think should be rest plus 1. What do you think? Yeah, I think should be rest plus 1. How about this? We always assign 1 because we always have 1. Right? Regardless, we always have 1. Yeah, I think this is not necessary. I think we can just say we'll always have 1. Regardless, we always have 1. That is so bad. Ga 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 ga. Ga 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 ga. Alright, let's see what's wrong this time. Nothing is wrong. This all 1. That's good. Where are we? We're here. So index is 0 and sorted nums is Lord. Okay. How do I do it? How do I reverse sort? I forgot. Sort reverse. There's a std something, a function that's handle greater. I put greater here. Greater. Come back here. Put greater. Try it again. Alright, I'm pretty sure the issue is in. Actually, I'm not sure what the issue is going to be, so let's just not talk about the issue. Could be the could be the prime score was wrong again. Alright, prime score I think is wrong. So I get the first one. So now is 6 is 3. Right now is 3. And so yeah, it should be rest plus 1 at the end again. Yes. But it's just plus 1 again at the end. It has to be larger than 1 then. Right? Okay, so here's my fix. I think I'll just still do the same thing. X mod 2. It should be equal to 0, right? Blah blah blah, and then we say rest plus x should die larger than 1. So let's finish this. And try it again. What? Okay, 1 or 2. This is correct. So we have 19 at the front, 18, 14. Okay, these two all look correct. So let's go. So index smaller than yes, k larger, k is 3. Auto p, so p. I can just do this. Sorry, 19 and 0, right? V is 19 and 0, so k larger than 0, and then p score 0 is smaller. This is true. So rest times v, so 19. Okay, so I plus plus and k minus minus. Okay, k is 2, I is 1, and this does not work because p score I is not small equal to that, so I will jump out. Yeah, so we basically use up 19, so plus plus index becomes 1. So now v is 18 and I is 5, right? And ooh, okay, so k is, yeah, this is right. So 19 times 18, whatever number, I think 342. I think it is 342, right? It's 342, yes. So I plus plus and k minus minus. Ooh, wait, hold on. This is a I6. You're supposed to be, it should be an error. Wow, I am accessing memory I'm not supposed to. All right, hold on. This is pretty bad. Memory leak. All right, I'm not sure if I change anything, so I'll have to do this one more time. Yeah, that was like a memory leak. Not memory leak, unsafe, right? Unsafe. All right, so we can try this. Not sure if like the complexity and everything. Well, apparently it was not right. There could be many factors. For example, it could be, honestly, I don't know in this case. Um, it's hard to debug this. Alright, so how do I debug this? I need to know its score, right? Maybe I have some online tools. Let's say prime factorization. Yes. Yes. Let's do this. So the first one is this 3289. So 3289. Calculate. So basically it's 3, right? Yeah, so I have 3. What's the second one? 2832. 2832. 2832. That's 3. What's the next one? 14858. 14858. 14858 is 4. Ooh wee. What's the next one? 22011. 22011. That's also 4. Alright, so we got 3289, 2832, 14858, and 22011. Next, so basically we will find the biggest, so we'll do 22011 is the first, but we cannot extend more to the right. And then we have 14858, and we can do one more time, 14858, and then we'll do 3289, 3289. Then we cannot do anymore. So 1, 2, 3, 4, 5, and then we do another 3289. So that's should be the answer. Let me see. We probably need the Python this. Let's go Python. We have PT Python, remember? Yeah. So we have 22011 times 14858. Right, hold a second. Well, I probably need to do mod. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have what? 22011 times 14858. Like I say, mod times 14858 mod times 3289, right? 3289 mod times 3289 mod. I remember there's one more 289 mod, right? 3289 so that's very different. What the hell? Two, three, four, five, 6. Okay, maybe is it because the mod? I don't know. Let me remove all the mod. So if I remove all the mod, and the Python is arbitrary, so this will work. So work, and we do this. Nope, it is. I think it's just there are many things because I didn't even get my output. What? What in the world is wrong with this one? I don't know. Let's put this into our test case. Just, you know, and I want to verify a few things. It's a 6, right? So we'll save this and let's run it. Oopsie doozy. Quit this and run this. Okay. All right. 3344. I think this is correct. Is this correct? So 3344. What are we looking for? Maximum possible score. Right? Maximum possible score. Well, the previous time I run it only once and I got it wrong. I got it right. Maximum possible score. And I got this one to go first. So I have 22011, yeah? Right? 22011. And the second operation will be 14858. That's the position 2. And I can expand, right? And then it's this. And I can expand once. Oh, my bad. Yeah, this is not right. I expand once. I do it. I expand once, and the last one shall be 2832. Mod is not defined. Yep, this is what I got. And okay, that I don't understand. I just don't understand. So I was following the logic, but expected is this. Like, wait, what? Let me read the question one more time. Right, I have this denotes starting from this, right? And then we'll choose anything that haven't been chosen before. Yes, we have that. And an element in it with the highest prime score of multiple such exit, choose the one with the smallest index. Yes. Oh, I see. I shall also expand to the left. I only expand to the right. You should expand to the left. And if it's smaller, yes. Oh my goodness. Okay, yeah, got it. Yeah, I know why it was wrong. Yeah, it was wrong. Indeed, it was wrong. It was oversight. Now we're gonna Alright, there's another way. Similarly, we can also expand to the left, but the requirement is all the expansion has a prime score strictly smaller than the one of the largest number. Yeah, so this is to go, yeah, expand right. So let's say expand to the right. We should do the same thing while k larger than 0 and I large equal to 0. Yes. Let's reset. I shall equal to p dot second minus 1, right? So r equal to this, and p score I is smaller than p score p dot second. Right, with that, so rest equal to rest times long v mod I minus k minus. All right, it's a fairly simple fix. Yeah, forgot you can also move to the left. Should actually give the user's test case. Right, that's the whole point. The whole point is to test the ones that we failed the last time. Yeah, so basically we can use 14858 one more time. Oh, now just one more time. I can use it. So this is once, twice, 3 times, 4, 5. 5 times. I can use it until 5 times. So basically, let me redo this. Basically, 1, 2, I can do 1, 4, 8, 5, 8 one more time, and one more time at 1, 4, 8, 5, 8. That is not correct. Wait, what? Really? Yeah, so I have, this is to go once, twice, 3 times, and 4 times, 5 times, right? So it should be 4 of this, 1, 2, 3, 4. And we also have 3, I don't know. Because I cannot extend to the left by this, right? One, 2, 3, 4. Yeah, I have 4. I don't know. We shouldn't have any overlap, right? I don't see how overlap is even possible, right? So p minus 1. Yeah, we have to have the current must be smaller, right? This doesn't allow. So it has to be smaller than that. One, 2, 3, 4. Oh, expand both. Damn. I can take this as well. Jeez, man. I can take this. Oh. Okay. Oh my. Oh my. Oh my. Oh my. Okay. 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 So basically, oh geez. The so the number of times we can expand to the right, and each one when we expand to the left, each one can count all those times. Oh my god. Okay. We can expand to the left. Another thing, it's important to note, right? It's important to know that when expanding to the left, each successful expansion carries all, right? Carries all the expansions on to the right, right? All extensions to the right. All right, so we need to count how many times, right? How many times? So int count right expansion count, right expand count. Oh. You probably can get it from I though. Yeah, I think I can get it from I. So I can put it here. So this is gonna be I minus p dot second, right? Actually plus 1. This is the number of times we get on the right hand side. And so each time once it's successful, right, then we just say again while k is larger than 0, int c shall be right expand count, right? This and c is larger than 0, we do this, and then c minus minus k minus minus. Well, we could do a better job in there actually. We can do power. So power C++ power with module pow. Oh, that is stupid. You don't have one built in? Probably not, and I have no intention to implement it, so I'll just do it this way. Right, it's just basically we do however many times that we need. Go through the loop, we'll multiply it until we're happy, right? Until we're happy. We get out. That's one expansion, right? We want to expand it here, so we got 1, 2, 3, 4, and we get all of them. Once we're done, we move I to, what the hell is I? Oh, I, yeah, we keep expanding, right? So now we do this, okay. Oh, man. A lot of things to consider. How did I solve this in one shot last time? I'm very impressed about myself, honestly. All right, now we can try. Ooh, is that the one that gave me issue? Okay, hold a second. How about 1? I don't know how it's 1. Huh. So you're telling me 1 should give me 0. Let me test this immediately. If x is equal to 1, return 0. Nope. That is still not right. Okay, so they are all prime or I think it's 0. Okay, so 1, 7, 11, 1, 5. So basically we do 11. So we have 11. All right, 11, 11, 1, 11, 5. And then can't do it. You cannot do it. Can't extend to the left because the left is not like I try to extend and then p score I, which is already minus 1, right? So p score I is, so it's like 0, 2, 3, 4, 402 plus 1, right? So right expansion is 3 and I is here, so p score I need to be smaller. It's not, so I cannot. So basically 11 times 11 is to the third, right? So next we're gonna go 7. So again we have 7. We go 1, 2, 3, and 4. Right? So we have 4. And so we have 4 already. So expand to the left, which is good. So we have another 4. Right? So basically we have 1, 2, 3, 4. Maybe it's duplicate. That's what I fear. We have duplicate. It's like starting from here, going all the way. There's no duplicate. I don't know. So this is 8. So which is 7 to the power of 8. We are at 11. So we have, okay, next one. 5. 5 by itself cannot extend to the right, but I can extend to the left, but only once. So 5 squared. Right, 5 squared. What do we have by doing this? 11 to the third, 7 to the 8th. So 11 to the third times 7 to the 8th times 5. Maybe we need to do the mod as well. Oh, so we do have one more, but we don't have any more options. We don't have any more options. So I got that. Then what? I think the next one is 1. Huh. But if next one is 1, it shouldn't make any difference. right? Oh, sure. Oh, I'm trying to think. Like, because I got 13, so I have one more. And even if I do times 1, yeah, next one will be 1. And then we'll come out and saying, yeah, it's not gonna work. Alright, interesting. I don't know why. Let's take a look. How? Again, I have no idea how I was able to solve this by myself. So I have 14 different tries. Alright, don't worry. It's we see the light at the end of the tunnel. All we need to do is just, keep digging and then it will come out. Right, so 11. I think we can just keep going, right? So yeah. So V is 11, I is 2. Yeah, 11, 2, so I can expand. So that's 1 time, 2 times, 3 times, get out. So we have right expand count. Oh, that is not right. That is not right. Right expand count should be 3 instead of 4. Ah, I see. I think here is the problem because I is pointing to the next one. So, oh, this is all on me. This is all on me. What? How? Now this one is not right. What in God's name? Doesn't matter. We will keep digging. Keep digging. I'm not really happy at the moment because it's really pissing me off. So we got almost, but almost is not enough. All right, let's see. Blah blah blah. So we got this and this. We basically do it once. Done. Come out. Yes. This is moving to the left. So I now is 2, but then this will be escape. Now index plus 1. Yep, and x plus 1, now it's the next one, blah blah, so now it's this and this. So basically for this, I do 1, expand 1, so I should get 2, right? I should get 2. 1, 2, get out. Yeah, so I got 2. And then coming in, I is 1, so it's smaller, so I go in. C is 2. Okay, K, what is K? K is 3. And we basically times this. C minus minus, K minus minus. We can do another one. K minus minus, get out. So now I get 2 of this, right? And then I minus minus. Oh, that is a bug. But don't do this here, because I already handled everything here. Okay, I already handled everything here, so this is not necessary. Alright. It's not that simple. So I'm still very surprised like how I was able to do it last time. Oh no. Oh no. Oh, that is not fair. That is not fair. That ain't fair, man. Well, I think there are. Oh my god. Don't do that to me. A lot of repeated computations. Because I can see repeats. Dude, that's harsh. That's really harsh. So I need some type of hashing here, right? I need some type of hashing here. But what's the largest number? Do we need largest number, or we just go 10 to the 5th, right? 10 to the 5th. It's not that bad. Okay, it's not that bad. So let's just do this. Let's get a vector int, right? We'll call it hash 10 to the 5th. 1, 2, 3, 4, 5, and then it can be 0, right? This is your score. Your score. Okay, so we put hash in it. Right, we'll put hash in it. So std vector int hash, right? If hash x is large equal to 0, return hash x. Otherwise, I forgot to do this. Oh, hold a second. I don't think I need it. If there's a 1, this will be 0. Right? X is 1. We don't do this. Yeah, it's fine. I can directly use hash x. Right, and here is also hash x. And of course, at the end, we return. And then we say hash x plus equal to x larger than 1. And we will return hash x. Alright, so a little upgrade. Added a little bit hash. Hopefully we'll get the performance a little bit better. Alright, let's see. Yeah, do we get a better performance? Of course, because I forgot the hash is just set up to -1. That is also a typo. Misjudgment. How? Because it was working earlier. Or remove the hash. What's the difference? I don't know. Honestly, don't know. How come it was correct the last time and incorrect this time? Alright, that's weird. We have to check. I believe this is a 2333 type of thing. It's like you put out fire here, and then fire happens somewhere else, and then you try to put out fire other places, and then this place starts to have fire. Oh wow. Well, of course. F4. My bad. I'd have the fix, but I didn't include it here. Okay, -1. Alright. So we're good. I build it. Coming back. F5. Run it. That is not right. Zero. Huh? What? That doesn't make any sense. It's 12, right? 12 is not in it yet. Twelve mod 2 is equal to 0, so it has to be at least 1. Oh, I see. Damn. Okay. Oh, that's all right. XX. Okay. So we'll do. This is all XX. So many places that can go wrong, and they do all go wrong, right? And we're gonna use this one again. All right, moment of truth. This, if this pass, I think pretty much will pass. Yeah. 1 hour 17 minutes for a hard problem. Oh my word. We have a overflow. Damn. I have what? Like what? How long does it take? Okay. Okay, it's here. I thought I can be cute, but apparently it doesn't work. I need to implement. I think you need to implement this like power A to the B. Is this the one? I'll steal. Stolen from. Yeah, that's fine. So basically, I think it's here. We just got a bit lazy, right? We just got a little bit lazy. So we just want a minimum of these two, right? We want a minimum of these two, and then we just say res shall equal to res times long power, right, power v, the power of minimum k and c, and then whole thing will be mod. Of course, this is also require another argument as mod. Right, so we do that. Don't do any of this. Right, k minus equal to std minimum k and c. Then we do this. All right. Oh. Yeah, that's why I think Python is easier in this sense, right? You don't have to worry about this. It has built-in support for all of these stupid stuff, and then it just gets, yeah. You see how much time got shaved off? It's about 5 times faster, right? You just need all these extra pieces to build. Oh my god. No way. No way, Jose. Are you kidding me? Are you kidding me? Holy crap. So what is this crap? Well, this crap means you're expanding to the right, okay? And when you expand to the left, so you just do once, right? You do once, so we speed up on that side. But after you're done, you move on to the next one, and you do it over again. Yep, that does cost more time. But what the hell? What the hell? So what I need to know is, given my current position, what is the most right I can get that is there a way to calculate that faster? So like I am at this position, I have my score, and I want to look to the right. I want to know the first time that a score bigger than me shows up. How can I quickly do that? So something bigger than me on the right. And also, if you go to the left, you want to do the same thing, right? Because you want to know the first one that's equal to you, right? The first one that's equal to you. I mean, we can do binary search. We record the indices for each prime score. So when the current one comes up, right, then you go for yeah, that doesn't work. You can try 2. I feel that's just too much work. All right, I'm gonna check what I did last time. Oh, dude. That probably helps as well. There's a left bound and a right bound. Okay, I think the ideal is given each number, we want to find the leftmost it can reach and the rightmost it can reach, right? And then within this boundary, you are the king. Yeah, this is available immediately because basically you have all of this times all of this. All right, so how do we find this left bound and the right bound? I'm trying to figure out if we can do it ourselves without really looking into this. How do we go left bound or right bound? I think we do have more. Yeah, we have one more test case on this time. Left bound and a right bound. Left bound is you start from this, right, and then you look to your left. You want to find the first that is smaller than you. No, that's equal to you. So you go, boom, you find that's equal to you. That's your left bound, right? And then you move on to the next one, right? And we move on to the next one. How can this help? I think I saw mono, so it's probably a monotonic array. So if we do a monotonic decreasing array, so if you're big, right, you're big, then you just pop until you find someone that's the same as you. And you cannot pop, so you put yourself there, right? You put yourself there. So monotonic decreasing array for looking to the left. So every time a new thing come in, I'll compare. If I am already smaller or equal to, then I don't even move. That you find left bound immediately. That's your left bound. right? That's a left bound. So each one we have a left bound, which is the leftmost that you can get, and the right bound is going to be similar, right? If you are it can be equal, so if it's equal you can keep popping, but if you find something bigger than you, then you cannot. So it's also a monotonic increasing, it's a monotonic increasing array. No, there's still a decreasing array, right? Still a decreasing array. So if you're bigger than, if you're bigger than everybody else, you can pop. But if it's the same, then you don't pop. And you go from right to left, right? You go from right to left. So you build like this. Okay, so this is yeah, we're failing. Well, the original idea doesn't work because we kept TLE. I had to check the previous solution. See, this is where that product works. It can tell you like you get stuck. Right? I checked the last time when I successfully did this in one shot. I used a monotonic array to find the boundary to the left and the right of each number. This can significantly reduce the amount of looping. Alright, so we need that. We still need the hash. We need the p-score. We need to do this, do this, do this. These are all necessary. Alright, they are all necessary. But now what we want to do is to find the boundaries. Right, we're going to find a boundary. So I probably will create a new function to do this. So I can say, right, vector int get low bound. Okay, so get low bound, I just need a vector int of nums and p-score. That's it. Right, and then we'll do similar thing, get high bound. Nums p-score. Right, so we have a low bound and high bound, and then we say nums. Actually, I don't need this. Do I need this? I do need this. Right, and then yeah, mono. Alright, so basically for int I 0 is smaller than n, I plus plus. Right, we'll go through every single one. And we'll say mono. Right, while mono is not empty, and yeah, so we say while mono dot empty and mono 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 size -1 is the last one. What do we put in there? It's index, right? We put index in there. So this is the last index. And I need a p-score of that index. So p-score of this index, if this is smaller, right? Smaller than p-score I, then mono dot pop back, because we don't want that one. But if it's equal, then we have no choice. So once we go through this, then we can put the boundaries, right? We can put the boundaries. So we say res I shall equal to, no, is mono empty, right? If mono empty is going to be 0. If it's not empty, it's going to be mono dot size this plus 1, because that's the one you cannot take, right? That's the one you cannot take. So it have to be plus 1. Once we're done, mono dot push back I, and at the end we'll return res. Okay, so here it's very similar. Size vector int res, and actually I res, yeah, that's fine. And vector int mono for int I equals n minus 1, large equals 0, I minus minus, go right to left while mono dot empty and p score mono dot size minus 1 is smaller or equal to p score I, right? Because it's on the right, so if it's smaller or equal to, then mono dot pop back, and then res I shall equal to mono dot will be empty. Yes, it will be. So mono dot empty. If it's empty, we're going to just do n minus 1, because we just get all the way towards the end, because everybody, you just has so big, you pop everybody out. Otherwise, we say mono dot size minus 1 minus 1, right? And mono dot push back I. Okay, and then I return res. All right, so this gives us a much faster. So essentially, we do this we have to run this one first, right? So we have to say get the boundaries, right? Get the boundaries. So we say std vector int left bound. So it should be call it low bound, right? So we can call it low bound. Ooh, we call it low bound. Get low bound nums and p score, right? And then we have another one, high bound, all right? And we'll do exactly the same thing, nums and p score, right? So we get a low bound, we get a high bound, we sort everything. Now what we can do is we will start by, okay, we have the, so none of this is necessary. Yeah, that's the beauty of the solution. None of this is necessary. We just go through n one by one, because I have the bound already. So int I equal to 0, I smaller than n, I plus plus, right? So for each number, I look into the bound, so we can say count. Right, so we say count low is low bound, it's actually I minus low bound I plus 1, right? And then we say count high is high bound I minus I plus 1. So anything within this is fair game, right? Anything within this is fair game. So now the count low basically is including the current, right? How many is in that range and how many in this range. Now we want to find out the total, right? So we can say total. Ooh, I'm not sure if it's int. So long total, right? I think it's count low multiplied by count high, but I might be wrong. So essentially, no, I think it's count low. hold on. Let me think one more time. So I have a count high, right? So for each count high, so each expansion to the low receive everything. So it's gonna be, I think it's gonna be count low minus 1 because I have to remove it by itself, multiplied by count high, right? Nope. I think it's just count low times count high. All right, this is the total that I can contribute. Now, once I've done that, then we can say res shall equal to res times power this is not right. This is not right. My bad. Let's use J. Okay, J. I want to use sorted num.size just to make sure that we understand what this is. This is still needed. Auto P will equal to sorted nums J, right? And then int v equal to p dot first, and then I equal to p dot second. Now we have all that, So this is gonna be v raised to c minimum k and total. Okay, so v raised to c and then do mod, and the whole thing do mod, and this need to return a long to make sure everything works. All right, no matching for call to min. What do you mean? Low min. I think this has to be long. I'll just change the signature. It's easy to change. Long. All right. So now we got the result upgraded, and then k minus equal to c. Int. Right, k minus this, and this is sorted nums, right? And k is larger than 0, right? All right, let's try it again. I'm not sure, right? I'm not sure at all. This is absolutely moonshot. Okay, it's not right and not correct at all. But we can check, right? But at least we are able to resolve one of the problem. Yeah, one problem at a time. And we change the logic a little bit. So I do expect things to not be as good at the beginning. So it's totally fine. All right. Where is my? I don't have one. I think I can do here. Let's try. Okay. We don't need any of the other things. Hash we don't need. P score is 1 1 1 1 1. That is correct. So we go here. So what we want is the low bound and high bound. Okay, let's say low bound and high bound. 0 to 0. All right. This 0, 1, 2, 3, 4. Yes, because you cannot do the same. Now high bound is not right, because for 0 the high bound is actually going to be all the way down. Because I'm taking this one, I can go all the way down. So the high bound is not right. So what do we do wrong in high bound? Well, when we do high bound, we are going from I is from the right to the left, right? And we do the same. The p-score on the right has to be if it's smaller or equal to, and if it's smaller or equal to, I will push. Right, if it's smaller or equal to, then I will pop it, because I can keep putting it in. And yeah, the push back. Oh. How is this not mono? It's not empty. So yeah, we put 4 in it at the beginning. Okay, next 3 comes in, and mono size minus 1 gives you 4. P-score 4 is 1. 1 is smaller or equal to this, so we'll pop it. And that become empty. So I count, see if it's empty. Then we should do n minus 1. Right? Alright, let's quit this. Yeah. High bound is not right. Let's put 1 here. A low bound. Huh. Alright, let me redo this. Let's put it inside high bound, because this is where we go wrong. Oh. Huh? Doesn't work? Oh, I see what happened. Coupled with all these ridiculous mistakes, that's why things don't work for you. Shouldn't even be surprised. Alright, let's see. Now, how do we look? Alright. Oh. Look at this. Look at this. Oh man. Oh, that took a long time, but okay. It counts as a failure because we did have to go to the previous solution to get inspirations. But boy, is this one. I feel a lot of achievement even despite the failures. It's not easy to code in C++. Come on, let's be honest with ourselves. It's not easy to, like, we have to do that. I mean, this is a heavy lifting. This is definitely heavy lifting, and I definitely did not realize I can do this. Um, it's very how should I say? Like, now I look back, it's very obvious that you can do like you can do this windows, right? You can do going to the right, like upper bound and lower bound, and you multiply them together. Now it seems to be very, very straightforward. But when I was doing it, I just think, okay, I expand to the right and expand to the left, and then realize that this is you can multiply them, right? You can multiply them. But dear Lord, this one took a long time. It's good. It's good. It's a failure, but I did the most heavy lifting. All right, let's put it that way. All right, that will be it. I look at it. It's a bloodbath. All right, it is absolutely a bloodbath. All right, I will see everyone tomorrow. Adios.